Cool, let's go. So, I have finals coming up, and I want to make one more video. I have a really neat idea, but it's going to require more time than I have, so I thought I would go over something that I kind of breezed over in my last video. Embeddings. So I wanted to take this time to explain them, but I also had a question that was bugging me. Do we really need them? I'll run an experiment to find out. First, what is an embedding? Well, an embedding is a variable that, once it's trained, we can separate into vectors that have meaning on their own. I've only ever seen this done with language modeling, but if you have another example, let me know in the comments down below. I'd be really interested. To explain this better, I'm going to need visuals, so I'm going to draw it. So, imagine we have two sentences. Alice likes shoes, and Bob likes jackets. In these two sentences, we have a vocabulary of 5 words. I should mention, if you already know this stuff and you want to skip to the testing, I'll put the timestamp in the description, or you can just scrub over to the part with code. That's what I always do. Alice, Bob, likes shoes, jackets. We can assign a number to these so we can put them in our model. Alice 1, Bob 2, so on and so forth. Once we have that, we can one-hot encode it, and that takes our vocabulary and makes a multi-dimensional data set where there's one dimension for each word. The sentence makes up the data of the dataset, where each word is a row. In that row, every dimension is a 0 except for the one corresponding to the word it is representing, which has a 1. Okay, so now we feed this into our model, and it goes through the embedding layer, which means each dimension is multiplied by 1 or multiple weights. But keep in mind, anything multiplied by 0 is 0, and anything multiplied by 1 is itself. So basically, now all you're doing is selecting which trained vector you want to send to the next step. These vectors have a really interesting property, in that they can be thought of as the semantic meaning of a word. I mean that you can take the vector for, as is most often the example, the word king, subtract the vector for the word man, and add woman, and you get a vector very close to the word queen. But there is a drawback. Have you figured it out yet? Well, let's pick a different vocabulary. My Alice computer runs quickly hot. So now we can make 2 sentences. Alice runs quickly. My computer runs hot. The word runs is in both sentences, but it has 2 meanings, which means that the embedding for it will be semantically wrong for at least one of them. So what's the solution? Well, there's an ongoing debate about this, but for the most part, in most language models, it's ignored. Let's look at the model that we looked at in the last video and bypass the embedding. Will we get more accuracy? So for this experiment, that's exactly what we're going to do. This can be done by modifying the call function to pass the input through the tf.onehot method instead of the embedding. What we see is the loss is in fact the same, but not using the embedding takes much longer. This makes perfect sense. Going back to the original shortcoming, getting rid of the embedding didn't really fix the problem. We still didn't specify the meaning for our homonyms. So really, we are processing the exact same information. So why did it take longer to run? Well, because our one-hot encoding is the same length as the number of words in our vocabulary. But I never said the embedding needed to be. And this is where the embedding is really necessary. We can use it for dimensionality reduction, leading to much faster processing. Now, like other forms of dimensionality reduction, I'm sure there is some information lost, but it really seems like the difference is negligible, for a massive boost in performance. Alright, we've gone through what embedding is, how it's used, and is it a good idea to use it. Obviously, this was not a super empirical test. We didn't actually run a hypothesis test. That'd be a good idea for a video in the future. So if you feel that I should or could improve the test in any way, go ahead and let me know in the comments. If you like this video, give it a thumbs up. Let me know in the comments what you'd like to see in the future, and go ahead and subscribe. I really appreciate it. Thank you very much.